All right, so we have been solving equations, writing equations. Now it's time to go back to inequalities and think about how that's related. So equations to inequalities today. So in the beginning of the solving equations unit, you have to write some true-false statements. So here I want you to think back and name what values the variable would have to be to make it true and what variables it would have to be false, just to get us warmed up. Please take a moment, do these, so pause, take a moment to do them, and then come back. Okay, how did we match up? Here, with the equations, it's pretty easy. There's one solution. So y would have to be 10 here. G would have to be 5, because 5 times 3 is 15, 10 plus 6 is 16. So for these two, we have one answer, and for the false, it's anything but our one answer. For inequalities, it's a little bit more difficult. So we can think, if we put a 10 in here, 10 plus 6 is not greater than 16. So it has to be any number greater than 10. So I proved it here, 11 plus 6 is 17, which is greater than 16. So if to be true, it has to be any number greater than 10. To be false, it's any number 10 or less. And I chose 9, because 9 plus 6, so 9 is less than 10. And it is 15, so 15 is not greater than 16. So it makes a false statement. If we put 10 in there, 10 is not greater than 16 either. And same with this one. So it's the identical, except now, because of this or equal to, it could be 10. So any number 10 or greater. Okay, so we are going to be writing inequalities and graphing inequalities. So Caleb has at least $5. So he has at least 5. So think about what that would look like. Could he have $5 exactly? Yes, he could have at least $5. So we know that 5 is a solution. Could he have more than that? If he had 6, is 6 at least 5? Yes, 6 is at least 5. Is 7 at least 5? Yes. So we know it could be 5, but it could be anything here. What about 5.1? If he had $5.10, would that be at least 5? Yes. So we know that the solution is all numbers that are greater than or equal to 5. So we're going to put the closed circle there to include that, and it's all the numbers going this way. Tarek has more than $5. So what could that be? Well, more than, it could be 6, it could be 7, it could be 8, it could be 5.25, it could be $5.01. Could it be 5 exactly? No, because it's more than. So it's going to be like this. Because we don't want to show that it includes 5, but because it could be $5.01, we're going to circle this but leave it open. That lets the reader of the graph know that it's not a data point itself, but anything above it is. So it's not included in the solution. Vanessa has at most $5. So if she had 5 exactly, would that be true? She has at most $5. Yes. So we're going to put a closed circle there because that is a solution. At most. If she had 6, would that make a true statement? 6 is at most 5. No, because it's more than 5. What about 4? 4 is at most 5. So anything less than this would work. But she can't be more than 5. La Chen has less than 5. So now, oops, sorry, I forgot my inequality up here. So x is less than but can include 5, like that. So now this is similar. He has a less than 5, so it would be 4, 3, could be $4.99 though. That might work. So we're going to circle but leave it open to let our reader know that it is not included, and then show the arrow going to all the numbers less than 5. So to review, you're using a closed circle for a greater than or equal to, or a less than or equal to. So this is the less than or equal to, greater than or equal to, open if it's not an or equal to. All right, what about some word problems? Kelly works for quick oil change. Customers have to wait. If they have to wait longer than 20 minutes, they do not get charged. The fastest oil change takes 6 minutes. So show all the possible customer wait times in which the customer charges, the company charges the customer. So we know that if they have to wait longer than 20 minutes, so they can wait exactly 20 minutes, but if they have to wait longer than 20 minutes, they don't get charged. But the fastest they've ever done is 6 minutes. So they could have an oil change that took exactly 6 minutes. And it's all of these in between. So we're going to, instead of having an arrow, we're just going to draw a line. Here are all of the solutions. It could be 6, it could be 9, it could be 12 and a half. All of these in between, but it can't be less than 6 or more than 20. All right, for these I'd like you to pause the video and see if you can write the inequality and graph it. Okay, write the inequality and graph it. Try it on your own and then come back. All right, here are my solutions. At most 2 meters. So is 2 meters at most 2 meters? Yes. Is 3 meters at most 2 meters? No. Is 1 at most 2? Yes. So the most we can have is 2. So that's included, and it goes this way. Okay? So x has to be less than or equal to 2. So it's all the numbers less than, including 2. Edith must read for a minimum of 20 minutes. So the very least she can read is 20 minutes. But she can certainly read more than that. So so the number of minutes is greater than or equal to 20. How'd you do? All right, so here we are writing a little bit more complicated. He needs to save 70 each week. Sorry, he saves 70 each week. He needs to save at least 2,800 to go on a trip. So how many weeks will he have to save? So we know that he saves 70, and hopefully now that you have been practicing writing, you know that he takes 70 times the number of weeks. And now he needs to save at least. If he saves more, that's okay. So the amount he saves must be greater than or equal to $2,800. And now we're going to solve this inequality. So we'll talk more about solving, but I'm hoping that you remember that if it's multiplied, you have to do the opposite. You have to divide. So now x is greater than or equal to, I'm going to cross out my zeros. So 7 goes into 28 4 times, but I have an extra 0. So he has to save at least $40 or more to be able to go on his trip. Can you pause and try this next one by yourself? Okay, so this is what I came up with. Clara has less than $75, so she doesn't have quite $75 to spend, and she wants to buy 3 pairs of shoes. So what can she afford? How many can she afford if they're all the same? So 3 pairs of shoes at some particular cost, we don't know, so that's our variable, has to be less than $75. So it was multiplied, so we had to use the multiplicative inverse to get rid of this. So we divided by 3, so x is less than 25. It can't be 25 exactly because she has less than 75. So we're going to put a circle here and make our arrow showing that all the possibilities are less than 25. Okay, perfect. Can you please do the assignment? Let me know if you have questions.